Right, binary. We humans, because we have 10 fingers, we use what's known as the Denary numbering system, which is called base 10. For example, number 9 base 10 means 9 units. 22 base 10 means 2 tens and 2 units. Okay, so if one person wants to tell another person a number, 22, the other person will understand. Unfortunately, computers are pretty stupid. If one computer wanted to say 22 to the other computer, I should say base 10, it just wasn't possible when computers were developed for them to be able to communicate the number 22 immediately. All they could do was signal on or off. If you can imagine, here is a cable, and all they could do was signal on, which was plus 5 volts, or off, which was 0 volts. So there you go. That's all you could do with it. That's all you can do. So what we've got here is not 10 numbers, but 2 numbers, 1 and 0. So this is called binary, as in bicycle and whatever, and it's called base 2, and written like this. Now that is not 101, that is 5 in base 10. Now you're wondering how I worked that out. Well, I'm about to show you. It's very simple. Okay. First of all, we need, I'm going to use a byte. A byte is 8 bits. A bit is a binary digit. 1 bit equals binary digit, aka 1 or 0. Okay, so 1 bit. So there's a bit, there's another bit, and collectively 8 of them is called a byte, spelt like that. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, 1 byte. Okay, so how do we convert a denary number into a binary number? Right, here we go then. Each bit in a byte has a denary value. So the first one here, the first bit, is worth 1. The second bit is worth 2. The third is worth 4, then 8, then 16, then 32, then 64, then 128. Can you see it's doubling each time? Now you'll recognise these numbers, because if I continued, the next one will be 256, then 512, then 1024, etc. So when you go in to buy RAM or buy a computer with RAM in it, and the guy says, oh, it's got 512 megabytes of RAM, you might think, 512, that's an odd number. It's not an odd number, it's because it's part of the binary numbering system. Okay, so I'm now going to convert the number 22 base 10 into binary. So in order to do that, I just have to work out what numbers in here make up 22. Well, 32 is too much, so I'm going to go with 16. So 16 means that I've got how many left? 6 left. So I can't use the 8. So I'll go with 4 and a 2. And then I'm just going to fill in zeros on everything else. Okay, so what have we got here then? Is 0, 0, 0, 1, 0, 1, 1, 0. You might notice I'm using that for a 0 because that distinguishes it from an O. Just a little aside there. Okay, so very straightforward then. 22 base 10 is 0, 0, 0, 1, 0, 1, 1, 0 base 2. And I've worked that out by going 16 plus 4 is 20. 20 plus 2 is 22. I'll just show you one more. So I start with my byte. 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay, right, larger number now. I'm going to go with I'm going to go with 160. So 160 base 10 is what? Well, 128, so we're going to have one of those, and that leaves us with 2 to 30, so 32. Oh, this is quite straightforward. So 128 plus 32 is 160, so the rest are zeros. So that's 1, 0, 1, 0, 0, 0, 0, 0, base 2. Easy. Right, so how big a number can we store in an 8-bit or a byte? Well, that's easy to work out, but let's work it out the long way. Okay, so here's our byte. So if we have ones in every single cell, that's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is equal to 255. And I know that because the next one along will be 256. So the maximum number in a byte will be 256 minus 1, which is 255. If you didn't get that, don't worry about it. We'll come on to that later on.